In this video, we are going to continue to talk about how to prove that two triangles are similar, and we're also going to take it one step further in these two-column proofs. So to kind of review back to chapter 3, if we know that two triangles are congruent, then the step that usually comes right after it is CP/CTC to prove a pair of corresponding angles or a pair of corresponding sides are congruent. So we know that congruent parts of congruent triangles are congruent. Now, similarly, we can use the definition of similar polygons to prove one of two things. So the first thing we know about the definition of similar polygons is that corresponding angles are congruent. And I'm just going to refer to it as similar triangles instead of similar polygons because that's what we're going to be working with in our two-column proofs. So that's no different than what CP/CTC says. Okay, but we can't use CP/CTC because corresponding sides are not congruent. Corresponding sides of similar triangles are proportional. So that's the second thing that we can prove. So anytime you're trying to prove that sides of a triangle are proportional, or the proportions, the ratios are congruent, you're going to use this second reason. So this will always come right after proving that two triangles are similar. So we'd have angle, angle, and then we take it one step further with one of these two reasons. Now we can even take it a step further than that. So when it's asking for a product of sides, so usually you'll see two sides multiplied together equals another two sides multiplied together. We're going to use the reason, the means extremes product theorem. Now we talked about this theorem back at the beginning of chapter 8, and remember that it's just kind of a fancy name for cross multiplying. So anytime you're trying to prove a product of sides is equal to a product of another two sides, that's when you're going to use the means extremes product theorem. So let's take a look at two examples. And the diagram already has tick marks labeled for you. So we have two angles congruent, and notice what we're trying to prove is a proportion. So we still need to start by proving two triangles similar before we can get to that extra step. So we just need one more pair of angles, and notice that both the small triangle and the large triangle, they share angle P, so we can use the reflexive property on angle P. And now we have enough information to prove that the two triangles are similar by angle, angle. So triangle PQT is the smaller angle, and that's similar to triangle PSR by steps 1 and 2. And now we're just going to take it that one step further. So think of this proportion here as part of the extended proportion that we've been writing over and over again. So notice that QT corresponds to SR. So that's kind of where this comes from. Normally we are used to writing out 3 ratios, but in the proofs that you'll be seeing, you're only going to be writing out 2 of them, and that's okay. So the ratio of QT over SR is equal to the ratio of TP over RP, and that's part of our extended proportion. The reason for that is the new reason we talked about. It's actually part of the definition of similar. We know that corresponding sides of similar triangles are proportional. So this is kind of like the CP/CTC for similar triangles. Okay, let's take a look at this last example, which is slightly different than the one that we just did. Start by labeling the diagram with the givens. We just have a set of parallel lines. So BD is parallel to AE. And we want to prove, notice, a product of sides. So again, first we need to prove two triangles similar before we can get to that point. So we need to get some angles congruent. There's more than one way of doing this, so I'll just do one way, but it's okay if you want to do it another way. So I'm going to say that angle 1 is congruent to angle 2, angle 3 is congruent to angle 4 because if two parallel lines are cut by a transversal, then corresponding angles are congruent. That's enough information for me to prove that the two triangles are similar now by angle. And now we can't just jump straight to our conclusion, because remember, the reason for the product is the means extremes product theorem, and that is kind of a fancy way of saying cross multiply. And in order for us to cross multiply, we would need some sort of proportion. So what always comes right after saying similar triangles? Well, I always tell you to write out the extended proportion. Now, do we need to write out the entire extended proportion? No, we don't need to write out the 3 ratios. We only need to write out the 2 ratios that are needed to prove that final statement. So I always start with whatever the first side is in my proof. So BC. And then I look at the order of the letters. So what side does BC correspond to in the other triangle? It corresponds to side AC. And then I look to see what other proportion do I need. So BC needs to be multiplied by AE. And then the other side in the first triangle is BD. And notice that BD and AE are also corresponding sides. So we're going to use that new reason that we used in the last proof, that corresponding sides of similar triangles are proportional. And then our final step is to say that those products are equal. So BC times AE is equal to AC times BD. And notice that I went from step 4 to step 5 just by simply cross multiplying. So I multiplied those two guys together, those two guys together, and that fancy name for cross multiplying is the means extremes product theorem. So hopefully now you have a better idea of how to prove triangles similar and then take it a couple steps further. So using that definition of similarity to take these 2-column proofs a couple steps further.